Venn diagrams and set operations. These are the objective. We will start with the universal set, and then we're going to talk about the Venn diagram. We use the Venn diagram to visualize the relation between two sets. We're going to find out the complement of a set, intersection of two sets, union of two sets. We do operations between sets, and we're going to use Venn diagram to do the set operations. Understand the meaning of and or between the sets, and then finally we're going to find out the total number of elements in set A or B. So these are the topic. So first of all, universal set means it's a general set that contains all elements under discussion. For example, you can say that, let's say, if we are talking about number, U represents all the numbers. If we are talking about the real numbers, then the universal set might be all real numbers. Inside the real number, we can create different sets that we represent using the circle. This is from John Venn. He was the one who created this Venn diagram. That's why it's called Venn diagram. And the Venn diagram we use to show the relationship between the sets. This circle is the set A. Outside the circle is the set A prime. Okay. And then difference between the set and then universal set is, universal set we always use the rectangle. Okay, two sets are disjoint if they don't have anything common, in which we can clearly see in this Venn diagram. You don't see anything common, they are separate. One set is a proper subset of another one. If the set of A is, all the sets of all the elements of A are also the elements of B, then that's a proper subset. This is from previous section. Two sets are equal if A is the proper subset of B and if A is the subset of B and B is the subset of A. If two sets have something common, this is how we draw them inside the Venn diagram. Set B and set A, both of them have something common, like this part is common. Common elements are in this region. Okay. Complement of a set. If you have a set and that is a proper subset of universal set, then anything outside that set can be, using the elements, anything outside of that set can be created another set that's called complement. So for example, let's say we're talking about, let's say our universal set is all natural number, and A is just 1, 2, 3, 4, 5. Then what do you have left over from the all natural number? A prime, or that is natural number starting from 6 and keep going, everything left over. That's the complement. Two sets, you can always, if they have a common elements, then you can denote that common sets by this A intersection B. And how do you find that? It is the set of X, such that X is inside A and X is inside B. So the elements supposed to be in both of them. So example, let's say A is 1, 2, 3 and B is 2, 3, 4, 5. Then A intersection B means how many elements are there? 2 and 3, 2 and 3. So you create new set with those two elements. So intersection means set of common elements. Union means it's everything from A, everything from B without repeating anything. So A union B is the set of all X, such that X supposed to be A or X supposed to be B. Example, let's go to the same example, 1, 2, 3, and then B is 2, 3, 4, 5. Then A union B means everything from here without repeating anything. So 1, 2, 3, we finish everything from here. We go and start from here, but 2 and 3, they are already here, so we don't repeat it. 4, 5. So A union B means this set. And if you try to take the intersection, the common, if you try to find the common between empty sets which doesn't have anything with any other sets, then that's supposed to be empty. If you take the union between any sets with the empty sets, that's supposed to be set itself. Some problem involve more than one set operation. So whenever we try to do the operation, always begin by performing any operation inside the parenthesis. Or means union in the set operation, and means intersection. So whenever you see A or B, you're talking about A union B. Whenever you see A and B, that means you're talking about the intersection. We can use this formula for finding the cardinality of A union B, which is the number of elements in A or B, both, is equal to the number of elements in A plus number of elements in B minus the number of elements in their intersection. Fill in the blanks so that resulting statement is true. The set of all elements in the universal set that are not in set A is called complement of set A, and it is symbolized by A prime or this A dash or A prime. Determine whether the statement is true or false. If the statement is false, make the necessary changes to produce a true statement. In a Venn diagram, disjoint sets are represented by circles that do not overlap. That's right. The statement is true. Describe a universal set U that includes all the elements in the given sets of the reverse. So universal sets means all the elements, like this one, this one, this one, this one, and this one. So the set of all reverse. The set of all reverse. Let universal is this set Q, R, S, T, U, V, W, X, Y, Z. A, B, and C are given. List the element in set A intersection B. A intersection means the common thing. Q, S, and then Y. So Q, S, and Y. That's the intersection between these two sets. How do you find the union? B union C. Everything from B, everything from C, but do not repeat anything. So it's supposed to be Q, S, Y, Z, but do not repeat the Y, Z, because Y, G, and Y, Z, they are repeated. So it would be Q, S, V, W, X, Y, Z. Q, S, there is no U. V, W, X, Y, Z. This is the union. Let C is this element. Find the C union empty set. Empty means it's not going to add anything else. So it's a C itself. C union empty is, say is C itself, because there are R, Z, N, Q, and K. These are the elements. So you just have to copy that. Look at the Venn diagram. A math tutor working with a small group of students asks each student when he or she had studied for class the previous weekend. Their responses are shown in the Venn diagram. Studied Saturday, studied Sunday. Sarah, Josh, they studied both. So the set of students who studied Saturday and Sunday, that's Sarah and Josh. A palindromic number is a natural number whose value does not change if its digits are reversed. Example of palindromic numbers are 1111, 454, and 261162. Use this definition to place 3442 in the correct region of the Venn diagram. Number is a natural number whose value doesn't change if digits are reversed. So if I reverse this one, it would be 2443, which is different than this number itself. So in the correct region, what is A? Example, when this definition, which of the following region of the Venn diagram does 3, 4, 4, 2 belongs to? I don't know which one is reason, so I need to read it again. A palindromic number is a natural number. Example of this, use the definition to place 3, 4, 4, 2. Three, four, four, two. Where U is the set of natural numbers, U is the set of natural number. Okay, this is a set of natural number. U is the set of natural. A is the palindromic number. A is the palindromic number, but this number is not. B is set of even numbers. This is the set of numbers. So 3, third one, because 3, 4, 4, 2 is the even number, and then but that's not. What is that called? Palindromic. That's why it's a region 3. Okay. Assume that A and B are not equal. Draw a Venn diagram that correctly illustrates the relationship between the sets. A intersection B is equal to B. So that means B has to be less than A, because intersection means common, and B and A are not equal, that B has to be small than A. So B has to be inside the A. Okay, that's all for this section.